Welcome back, dear students. So today we'll again do a kind of substitution only. So again, let me call this to be the integration by substitution only. Okay, fine. Now here we are going to integrate by making this kind of substitution. Okay, so basically this is a trigonometric substitution. So as you all are aware of these formula, whenever you see this, that time you have to take x equals to a sine theta. Okay, x in this case, in such cases you take x equals to a tan theta. In this case you can take x equals to a sec theta, and in this case you have to take x equals to a cos theta. You need to remember these because they are very, very important for you. Okay, so when you make these substitutions, then any of these will be useful. All right, so this thing you need to remember for today's problems. Okay, and next we are going to talk about integral of the form Okay, so let me write the integral fx by gx dx. Okay, where fx and gx are polynomials. Okay, and degree of fx, remember degree of fx is greater than or equal to degree of gx. Now let's understand what is the meaning of this. Okay, so suppose you have got a polynomial. For example, let me call this as fx equals to ax cube plus bx plus c. Now if I ask you what is degree of this polynomial, then your degree will be the highest power of the variable, that is 3. So that means degree of fx, which is written as degree of fx, is 3 in this case. Okay, so for this degree is 3, and similarly if I give you gx is equal to, for example, x to the power 4 plus 1, then your degree will be 4 for g. So basically in this integral, if the degree of this numerator is greater than degree of gx, then you have to make the degree of numerator less. Now how do you make it less? By dividing. Okay, so you have to, the rule is you have to divide fx by gx. Okay, and you have to make use of the formula. So very important formula, let me write it here for you. So the formula is divisor, this is dividend. Dividend is equals to divisor into quotient plus remainder. So after dividing, you have to apply this formula. Okay, this is very, very important formula for you. So you may pause the video and note down the rule here. Now after dividing the numerator in earlier form, you might get wonder what happens after division. So after division you will get fractions. Okay, so you will get, let me take, okay, so you had earlier fx by gx dx. Now let me assume that after division you will get a fraction. Basically you will get a mixed fraction, isn't it? Because numerator is greater, so you will get a new mixed fraction, and apart from this number in mixed fraction, whatever number you get, that in that number your numerator will be having less degree. Okay, so numerator's degree will be lesser than that of denominator. So when it happens, then your this part, okay, so this part falls under these categories. Okay, any of these categories, and when it falls under these categories, then these can be represented in this way. Okay, now you might be wondering what is a b c and all. You have to find them. Okay, and this kind of special integration is known as integration by partial fraction. Okay, so today's main topic is in fact integration by partial fraction. No doubt we are going to see some of the problems which are of integration by trigonometric substitution as well. Okay, so let's begin with the sums on integration for the day. Okay, so let's see the first question, and in fact this is a formula as you all know. So let's see how to arrive at this particular formula. Okay, so we have this integral. Okay, so let me call this an integral I. So I is equal to integral dx by x square minus a square, isn't it? Now can I write this as 1 by x minus a into x plus a? Can I do that? Into dx? Yes, I can do that. Now you have already copied your integration using partial fraction, isn't it? Now let me keep it in front of you. Okay, now just compare this with any of these. This falls under the first category, isn't it? Because you have got what should I say, the product of two numbers, that is x minus a and x minus b in the denominator. In the similar way we have got in the denominator same one, isn't it? And clearly see, this is a quadratic and in the numerator you have got 1, isn't it? So that is the degree of the numerator is lesser than that of the denominator. So in such case, as I said earlier, you have to apply integration by partial fraction. Now the rule says, just now you have seen that this, okay, this fraction, forget about the integral sign, this fraction can be written as 1 by x minus a into x plus a, can be written as a by one fraction, that is x minus a, plus other one is b by x minus b, and which is in fact x plus a. Now what to do here, see carefully. So this is x minus a into x plus a, in the numerator we have got 1, and this can be written as x minus a into x plus a. Okay, so this is the LCM, isn't it? Now simplify this. So divide this LCM by x minus a, you will get x plus a. So you get a into x plus a, plus you have got b, you have to write here x minus a. Now open up the bracket out here. So you will get x minus a into x plus a. Okay, now let's separate x terms and the constant term. So for example, here you see that a plus b x, isn't it? Here we have ax, here we have got bx, so take out x common, you will get a plus b. Now in the remaining you have aa minus ba, isn't it? Okay, now here this is x minus a into x plus a. Now you know this 1 can be written as 0 into x plus 1. Now why have I done that? Because I want to make x term also, because we have got x term here also, isn't it? So the same thing I am going to do here. So we have so comparing here, so you see that this and this gets cancelled, and similarly this and this gets cancelled. So comparing both sides, you see that the coefficient of x here is a plus b, yes, and the coefficient of x here is 0, isn't it? So a plus b will be equals to 0. Let me call this to be equation number 1, and you have aa minus ba is equal to 1, isn't it? Because this is the constant term and this is also constant term, so let me call this to be equation 2. Now you need to solve 1 and 2 and find the value of capital A and capital B. Okay, let's do that. Let's multiply this with a and let's multiply with this with 1. So you will get from here aa plus ba is equal to 0 into a is 0, so you have aa minus ba is equal to 1. Okay, so if you want to subtract, that's also fine. If you want to subtract, that's also fine. So let's subtract here. So I'm sorry, let's add it. So aa plus aa is 2aa, and these two gets cancelled, so this becomes 1. So from here, what is the value of a? The value of a turns out to be 1 by 2a, isn't it? Now from 1 you see that a plus b, that is a is 1 by 2a plus b is equal to 0, isn't it? That is the value of b from here turns out to be minus 1 by 2a. Okay, so let's get back to our work, that is this one. Okay, So this integral, therefore integral I can be written as, so instead of this, see here carefully, can I write this? Yes. So if I do that, then this can be written as a. Okay, so a is a constant, can be kept outside, so you have dx by x minus a, plus similarly you have got b integral dx by x plus a. Okay, now what's the value of a? A is this one, that is 1 by 2a. Now what is this? This is log of integral dx by x minus a is log of x minus a, minus b is 1 by 2a log, this is x plus a. Okay, so you see that there is something common, 1 by 2a is common, so you see that this is log of x minus a minus, okay, 1 by 2a is outside, so you have log of x plus a. No doubt you have to put a constant of integration as well. Now what is this? Log a minus log b, which is log a by b. You will get this much, isn't it? So the last step you will write by yourself, and last step you have to write this. So you may pause the video and note it down. Okay, so let's have a look at this now. Here you have this one integral. Okay, so let I is equal to integral dx by x square minus x. Now can you factorize this? See, whenever you are trying or whenever you are doing integration using partial fraction, let's try to always factorize the denominator. Okay, so in this case you see that this can be factorized and can be kept as x into x minus 1, isn't it? Now, okay, so if you want to write 1 here and dx here, that will be better. Then you will take, okay, so this is your x minus a, this is your x minus b, so you have to take let x into x minus 1 is equal to a by first fraction, first factor plus b by the second factor, that is x minus a, x minus 1. So as usual we will solve it, 1 by x into x minus 1 plus this, this is equal to, so x into x minus 1 is the LCM, so you will get a into x minus 1 plus bx, that is again you will write 0x plus 1 divided by x into x minus 1. Okay, here it becomes x into x minus 1, so this is a plus b x minus a, isn't it? So when you compare both sides, comparing, you see that a plus b is equal to 0, call this as equation 1, and this constant term is minus a here, so minus a turns out to be equals to 1, which implies that a is minus 1. Let me call this as 2. Okay, now you have got the value of a, isn't it? Can't you find the value of b using 1? Yes, so using 2 in 1, we have a is minus 1, so minus 1 plus b is equal to 0, which gives you b is equals to 1. So we got the value of b and we got the value of a as well. So let's get back to our work. So therefore your I, integral I will be, so 1 by this can be written as this much, isn't it? That is a by x plus b by x minus 1, you have got dx. So this can be written as a into integral of dx by x plus b into integral dx by x minus 1. Okay, so you have a is how much? A is minus 1. Okay, minus 1, so this is log x, isn't it? Integral of this is log x plus b is 1, so 1 into log of x minus 1. Okay, so you can put a modulus out here. So this can be written as log x minus 1 minus log x with constant of integration, do not forget it. So this becomes log a minus b, which is log a by b. So that's what we need to verify, isn't it? So you may pause the video and note it down. Now let's see this again. See, if you compare your integration by partial fraction, this one, okay, there again you have got the same thing. See here carefully. So you have product, see here carefully, in fact I have not explained you this properly. Here you see that this is linear, this is linear. Here two factors are repeating, that's why whole square is written, isn't it? See, if this b is a, then this becomes x minus a into x minus a, which is x minus a square. So that time you have to take different substitution. All right, here you have got three different linear, okay, so all of these are linear, isn't it? So you have got product of linear factors here. Similarly here you have got two factors in fact are repeating, so that's why you have got square and one factor is non-repeating. Okay, and one more thing, now the last case, one is linear, another is quadratic. See, this is quadratic, but this cannot be factorized further. Okay, cannot be factorized. So this cannot be factorized, so in that case you have to take this kind of substitution. Now compare this with these. You have got this is linear, this is linear, so that's why this will again fall under the first category. Okay, so we have, or in fact we can write this, okay, as, let this fraction, okay, that is x by 2x plus 1 into x plus 1. So let me write this as a by 2x plus 1 plus b by x plus 1. Okay, so in that case we get, again as usual, you will write 2x plus 1 into x plus 1. So let me write this as 1 into x plus 0. Can I do that? Yes. So this can be, I am directly writing for you. Okay, so this 2x plus 1 into x plus 1. Okay, so I think you will get, okay, let me do it serially only. So we have x plus 1 plus b into 2x plus 1. Okay, so we have 1 into x plus 0 divided by 2x plus 1 into x plus 1 is equal to, so you have 2x plus 1 into x plus 1. So when you take x common, then you get a from here, and from here you get 2b, isn't it? So the quotient of x here is a plus 2b, and here you get constant term is a plus this becomes b. Okay, so again comparing, you see that the value of a plus b is 0, a plus b is 0, and a plus 2b is equals to 1, isn't it? The quotient of x is this much and this is equals to 1. Now one thing that you can do here is, you can call this as 1 and you can call this as 2. Okay, so you subtract 1 from 2. It's your choice how you want to find the value of a and b. Okay, so first is a plus 2b, and you have to subtract a, and when you subtract this becomes minus. So we have in the right hand side 1 minus 0, so a and a gets cancelled, isn't it? So 2b minus b is b, so this turns out to be 1. So the value of b is 1, and from 1 a plus b is how much? 1 is equals to 0, isn't it? That is, the value of a turns out to be minus 1. Okay, so this is my value for a here. So let's get back to our original thing. So therefore your integral I can be written as, if this is your I, this can be written as, so instead of this part I am writing a by 2x plus 1 plus b by x plus 1 dx, which in turn can be written as a integral dx by 2x plus 1 plus b integral dx by x plus 1. Okay, we'll put the value of a and b later. First let's see this integral. Now to do this integral you have to make some substitution. See, make sure that whenever you do integration using partial fraction, the quotient of x is 1. okay, plus 1, not negative also, but here the quotient is 2. So if you want to make this as 1, you have to again do substitution, okay, and the substitution is very easy. So let 2x plus 1 is equals to t, okay. So from here you get dx is equals to dt by 2. So therefore your integral I will change into a is minus 1 integral, see here carefully, dx is dt by 2, isn't it? So that's why this 1 by 2 can be kept outside, becomes this much. So this becomes dx becomes dt only, by 2 is already kept outside, divided by 2x plus 1 is t, okay, plus b is 1 into integral of dx by x plus 1. See here the coefficient of x is already plus 1, so we don't have any problem here. So minus half, this becomes log t plus 1 into this becomes log of x plus 1. So you can put a modulus here also. So you will put a constant of integration. Now minus half log of t is how much? T is 2x plus 1 plus this is log x plus 1 with constant of integration. Now if you do the rearrangement, take this to the front and take this to the second, you get log x plus 1 minus half of log 2x plus 1 with constant of integration, and that's what you need to show here. So you may pause the video and note it down. Okay, now again this time let me keep my sheet here. Let's compare this. Okay, now this falls under which category? If you see here carefully, the power or the degree of the denominator is x square into x square, that is x to the power 4. That is the degree for the denominator is 4. But here if you check, the maximum degree that you can reach is up to 3 only, because the last one is having the maximum, that's x into x square is x cube, isn't it? That means this do not fall under any of these category. Yes? Now how to do this? If you see here carefully, we are not interested with the dx, are we? No, we don't have any dx out here. We are interested only with this fraction, isn't it? Okay, now if I see here x square is there. If I write x square as t, then this becomes 2t plus 1 divided by t into t plus 1, which again falls under the first category, isn't it? So here you need not worry at all. Let's see how to do this. Okay, so we take 2x square plus 1 by x square into x square plus 1 as, see here carefully, a by one of the factors x square, another factor is x square plus 1. See, you have to practice a few more problems, you will get familiarized with the concept. Okay, so we have x square into x square plus 1. So let's first simplify this. So this becomes x square into x square plus 1. So you have a into x square plus 1 plus b x square, isn't it? Okay, so let me write it as 2x square plus 1. So this becomes 2x square plus 1 divided by x square into x square plus 1 is equal to, so this is a plus b x square plus a by x square into x square plus 1. Okay, so comparing, now when you compare, you see that a, that is the constant term here, is 1, so a is equals to 1, and a plus b, that is the coefficient of x square, is a plus b, and here it is 2, isn't it? So from here we see that a is 1, so we know that a is 1, so instead of a I have written 1. So from here also we see that b turns out to be 1. Okay, so in this case, therefore I write integral I. Okay, so I is equal to, okay, let me write here, therefore integral I is equal to, so instead of this, can I write a by x square plus b by x square plus 1 dx? Can I do that? Yes. So this can be written as a integral dx by x square plus b integral dx by x square plus 1. Okay, now this is a integral of x to the power minus 2 dx, isn't it? Okay, plus b, this can be written as dx by integral dx by 1 plus x square, isn't it? Now this can be written as, okay, so let me put the value of a is 1, so 1 into, this is x to the power n plus 1 divided by n plus 1, plus b is also 1. Now this is tan inverse x, isn't it? Direct formula. So 1 into tan inverse x is tan inverse x minus, this is x to the power, okay, so this becomes minus 1, so that's why minus, and this is 1 x to the power minus 1, which is 1 by x, isn't it? We'll put a constant of integration here, so that's what we need to verify. So you may pause the video and note it down. Okay, let's observe this now. So if I call this as your integral I, okay, so your I becomes, okay, so can I write this as dx by x square whole square minus 1 square? Can I do that? Yes, I can. So this can be written as dx by x square minus 1 into x square plus 1. Okay, now again you see that the degree of denominator is 4, so we don't have any choice here. Okay, but we know, or rather we have just seen that this, if I write this dx out here, then we have 1 here, so we can write this 1 by x square minus 1 into x square plus 1 as, so think that x square is just t, so this becomes 1 by t minus 1 into t plus 1, so which again falls under the first category. Okay, so this can be written as a by x square minus 1 plus b by x square plus 1. So therefore from here you have, so let's write 0 into x square plus 1 here, so we have x square minus 1 into x square plus 1 is equals to, so this becomes a plus b x square, yes, plus a minus b divided by x square minus 1 into x square plus 1. Okay, so again this 2 gets cancelled, this and this gets cancelled, so from here comparing you get a plus b is equals to, the coefficient of x square is 0, okay, call this as equation 1, and you have a minus b, that constant term turns out to be 1. Okay, let me call this as equation 2. So if you add these two, then this and this gets cancelled, so you get 2a is equals to 1, isn't it? And from here the value of a turns out to be half. Okay, so using 1, okay, using 1 you get b is equals to minus a, isn't it? Minus a, which is minus half. Okay, so we got the value of a and b, isn't it? Now let's substitute the value of a and b. So therefore your integral I can be written as, so this, isn't it? So we have a by x square minus 1 plus b by x square plus 1 dx. Okay, so we have a, what is a? A is half, so half integral dx by x square minus 1 plus b, b is minus half, so that's why minus half integral dx by x square plus 1. Okay, so let's simplify this further, so this can be written as dx by x square minus 1 square minus half integral dx by, this can be written as 1 plus x square. Now isn't this one the first problem that we solved for the day? Now you know that this is 1 by 2 is there, equal into 1 by 2a, what is a? A is 1, okay, log x minus a divided by x plus a, isn't it? Okay, minus half, now what is this? This is direct formula tan inverse x with constant of integration. Now simplify this, this is 1 by 4, so you have log x minus 1 divided by x plus 1 minus half tan inverse x plus c. So that's what we need to verify. So pause it and note it down. Okay, so let's have a look at this question. Now here, first and foremost, you have to do a substitution. Okay, now here, in fact, I'm not going to solve the entire problem. I'll just give you some hint. So let's substitute sin x is equals to t. So from here you will get cos x after differentiation of sin x is cos x, dx is equals to dt. So if you call this as I, your integral I will change to, so x cos x dx is dt by 1 plus sin x is t into 2 plus sin x is again t. Okay, so again falls under the first category. So how much is this going to be? You will calculate by yourself. So next again we'll have a same kind of integral here. So if you call this as I, again do the substitution. So in this case you take e to the power x is equals to t. Now differentiate this, you will get e to the power x dx equals to dt, isn't it? Yes. So therefore your integral I will change into, this is how much, dt. So you get dt by e to the power x is t. So this becomes t minus a into, this becomes t minus b, and after that you will do by yourself. Okay. Now let's observe this. Now from here onwards we will see the problems where you have to use trigonometric substitution. Okay. Now let's first simplify this left hand side. So if I call this as integral I, this I can be written as integral dx by, see here carefully. So can I write this as x square plus 2 square, see here carefully, 2 square into square root of x square plus 2 square. Can I do that? Yes. So whenever you have this, as I said earlier, in such cases you have to take substitution to be x equals to a tan theta. Okay. So therefore let x equals to a tan theta, and what is a? A is 2. So we take 2 tan theta here. Okay. So let's see how much do we get. So here differentiating you will get dx is equals to 2. Now differentiation of sec theta is, tan theta is sec square theta d theta. So that's why your integral I will change into, see here carefully, dx is 2 sec square theta d theta divided by, so you have x square is 2, okay, let me write it, 2 tan theta whole square instead of x square plus 2 square is, you know, this is 4. So we have outside this one, and within square root sign again we have got the same thing, that is 2 tan theta whole square plus 4. Okay. Now this can be written as 2 sec square theta d theta. Okay. Now from this 4 is common, so can be written as tan square theta plus 1. Yes. And similarly this can be written as square root of 4 is common, so tan square theta plus 1. Okay. So you know that sec square theta is equal to 1 plus tan square theta, isn't it? So 1 plus tan square theta, that is these two, can be written as sec square theta. Okay. So we have 2 sec square theta d theta divided by, see here carefully, this is 4 and this is sec square theta into, the square root of 4 is 2, and again this is square root of sec square theta. 2 and 2 gets cancelled, sec square theta gets cancelled. So this can be written as is equal to 1 by 4 is constant, can be kept outside integral sign. So d theta by square root of sec square theta is sec theta, isn't it? And what is this? 1 by 4. Okay. So from here you get integral cos theta d theta, isn't it? Okay. And what is the integral of cos theta? It is sin theta. Okay, we will put a constant of integration. Okay, now you know that from here you see that, okay, let me do it here now. Okay, so tan theta turns out to be how much? X by 2. Okay, so from here you calculate what is your sin theta, because ultimately you need the value of sin theta, isn't it? Okay, so from here you find sec square theta. So sec square theta turns out to be 1 plus tan square theta, that is x square by 4. That is 4 plus x square by x square. I'm sorry, by 4, isn't it? So from here you get cos square theta is equal to 4 by x square plus 4, isn't it? Now from that you have to calculate the value of sin theta, and you know the sin theta, the sin square theta can be written as, see here carefully, sin square theta can be written as 1 minus cos square theta, which is 4 by x square plus 4. Simplify this, this turns out to be x square plus 4 minus 4 by x square plus 4. So these two gets cancelled, so you get x square by x square plus 4, and you need to find the value of sin theta, isn't it? So sin theta turns out to be, square root of this is x by square root of x square plus 4. So that's why this can be written as 1 by 4 sin theta is x by square root of x square plus 4. Did we get this much? Yes, with a constant of integration. So after this only you will do this part, okay? That is, you will complete this part, then only you will start from here. So you may pause the video and note it down. So let's observe this now. Now if you remember, in such kind of questions, okay, so in such kind of question where you have a plus square root of a plus x divided by a minus x, then the substitution that you are going to make here will be x equals to a cos theta. So basically if I call this to be I, I'll take x equals to a cos theta. A is 1 here, so it will be 1 cos theta, which is nothing but this cos theta. So from here you see that what is dx? Dx turns out to be minus sin theta d theta, isn't it? Okay, so therefore your integral I will change into, I'm sorry, I have forgotten integral sign. So integral becomes integral square root of 1 plus cos theta, okay, divided by 1 minus cos theta dx is negative sin theta d theta, isn't it? Okay, now this negative will be kept outside. So this is what? This is, all of you know that this is tan square theta by 2, isn't it? So square root of tan square theta by 2. So tan square theta by 2, and this sin theta is there, no? So this sin theta can be written as 2 sin theta by 2 cos theta by 2 d theta. Okay, so you have to see carefully, minus integral of, this is tan theta by 2, isn't it? So this becomes sin theta by 2 by cos theta by 2 into 2 sin theta by 2 cos theta by 2 d theta. This 2 gets cancelled, so this is minus sin, okay, so this is 2 sin square theta by 2 d theta, isn't it? And all of you know that this 2 sin square theta by 2 can be written as 1 minus cos theta d theta, right? So basically this integral changes to integral cos theta minus 1 d theta. Okay, so we have integral cos theta d theta minus d theta, isn't it? So we have, what is integral cos theta d theta? It is this sin theta, isn't it? Minus this is theta with constant of integration. Now what is theta from here? Theta is cos inverse x, isn't it? Okay, so if you put the value here, you will get sin, okay, so let me write this as sin as square root of 1 minus cos square theta, okay, minus theta plus c. So we have 1 minus, what is cos theta? Actually cos theta is x, so that's why this becomes x square, minus theta is cos inverse x with constant of integration. So that's what we need to show here. Okay, so let's observe this question now. Here, if I call this to be integral I, okay, this integral I can be written as x dx by 2 into this x to the power 4 can be written as x square whole square minus 3x square plus 2. Now here basically I'm trying to do the substitution. So let's see how to do the substitution. So let x square is equals to t. So from here you get 2x dx, or let me directly write x dx will be equals to dt by 2. Okay, so in that case your integral I will change into, so x dx is half dt, so let me keep half outside. So you have dt by, see here carefully, so this is 2t square, isn't it? So 2t square, because x square is t, minus 3t plus 2, isn't it? Okay, now your job is to factorize the denominator. Okay, so dt by, okay, so if you use the middle term, this can be written as 2t square minus 4t minus t, isn't it? Okay, so we have plus 2 here. So you see that half from these two, from this one and this one, you have something common. And what is that common part? The common part is 2t, so you get t minus 2, and from this you take out minus common, so this becomes t minus 2. Okay, so half integral dt by, so t minus 2 is common and you get 2t minus 1 from here. Okay, now will you be able to apply integration by partial fraction again, the first case? Yes, so apply that, and after that at last substitute the value of t to be x square, so you will get your answer to be this much. So you may pause the video and note it down. Okay, so at the same time, since we are going to do one more sum, which is going to be my last question, that particular integral is going to fall under this category. Now this is your new kind of integral. Okay, so here you have in the denominator x minus a to the power m into x minus b to the power n. You have here a and b are not equal to each other, please remember. Okay, and m and n are positive integers. Okay, so they belongs to positive integers, z plus. Okay, now in that case the substitution that you have to make here is x minus a, okay, is equals to this much. So from here if you calculate the value of x, this turns out to be this much. Differentiate this in order to get dx, so dx will be this much. So you have x minus a, this turns out to be this much, and x minus b turns out to be this much. You need to remember this, or if you don't remember this, at least you need to remember this. Okay, this substitution needs to be done. Okay, so you may pause the video and note down the rule. Okay, so let's take this integral now. So again, this particular integral falls under the integral we have seen just now. Okay, so as you all know, the rule says that we have to take, okay, so let x minus a is equals to x minus b into z. Okay, so you can instead take x minus b equals to x minus a into z. That also can be done. Okay, now as you all know, from here you have the value of x is equal to, so the value of x is equals to a minus bz whole divided by 1 minus z, is it? Yeah, it is 1 minus z, and from here after differentiation you get dx is equal to a minus b divided by 1 minus z whole square dz. Okay, so this is my integral I, remember. Okay, so from here, okay, so as you all know the value of, okay, so for now we'll keep it this much, so we'll substitute the value of x minus a and x minus b later. So we get, okay, so therefore your integral I will become, okay, let me write the value of x minus b for you. Okay, so the value of x minus b will be, as you all know, x minus b will be how much? It will be a minus b divided by 1 minus z. Okay, so just subtract minus b from, just subtract b from this, so you will get x minus b, and this will turn out to be this much. Okay, so you can verify that. So therefore your integral I will change into, okay, so your integral I will change into integral, see here carefully, so dx is there, isn't it? So where's dx? Yeah, dx. So okay, let me write it fully first. So dx by x minus b whole cube, okay, x minus b whole cube is there, isn't it? Okay, and x minus a whole square can be written as this whole square. So this becomes x minus b whole square z square, isn't it? So this becomes, see here carefully, integral dx. Now let's substitute the value of dx. So dx is this much, isn't it? So this is a minus b dz, see here carefully, divided by 1 minus z whole square. Okay, now this is x minus b whole to the power 5, isn't it? So this can be written as x minus b is a minus b by 1 minus z whole to the power 5, okay, into, you have got z square also, remember, right? Okay, so we got this much. So let's check out once again. So we got the value of dx. So this together is to the power 5 and z square this. Yeah, that's all. Now, okay, so I don't have space here, so let me draw a line. Okay, so you see that you have got 1 minus z whole square. Here 1 minus z to the power 5, isn't it? Whole to the power 5. So, okay, so let me write this integral as, so this a minus b is there, isn't it? So a minus b can be kept outside. And similarly, you have got a minus b whole to the power 5 can be kept outside. So a minus b whole to the power 5. Integral, so you have got dz, okay, so 1 minus z to the power 5 will go to the numerator, 1 minus z to whole to the power 5 goes to the numerator. You have got z square into, you have 1 minus z whole square here, right? So as usual, this and this gets cancelled, okay, so you have this and this gets cancelled, so only 4 is left. So you have 1 by a minus b whole to the power 4 integral 1 minus z cube, z whole cube by z square dz, isn't it? Okay, now your work is easy, right? So you just need to open up the bracket. So 1 by a minus b whole to the power 4 is there. So this is, okay, so this is integral of, okay, so this can be written as a minus b whole cube, and a minus b whole cube is a cube minus 3a square b plus 3a b square minus b cube, isn't it? So divided by, we have got z square with us, dz, okay. So 1 by a minus b whole to the power 4. So we have got different integrals now. So this is 1 cube by z square is z to the power minus 2 dz, okay. So this is minus 3 integral z by z square is dz by z, yes, plus this is 3 integral just z square by z square is dz minus this is z cube by z square is just z dz, okay. Now your work is very easy. So will you be able to complete this by yourself? Yes. So please do this, put a constant of integration and substitute the value of z, remember, okay. So the value of z from here turns out to be x minus a divided by x minus b, okay. So at last you will substitute the value of z to be x minus a divided by x minus b. You will definitely get this much. So with this we close for the day. Thank you very much.